So my basic premise here is that the embed plate member is better in a wide variety of situations. So I'm going to have Matt here take you through and show you some of those situations. So should we start off with the most basic bearing plate?
Yep, so we're going to do a bearing plate for a beam. And we'll start out by zooming in here. We've got a beam. Its work point is right to the face of the wall. And then we've given it 6 inches of bearing through its setback. You gasped.
If you're a checker out there, this will make you very happy because the important point is always going to be that face of the wall, and then you add your embed if after. If your detailers are making you back figure that without using their setbacks, they're bad people, and you should do bad things to them.
All right, so when we select the add member, we're going to go to Embed Plate BV.
And this goes all the way back to at least 2017, right?
Yes, I believe this came into play in 2015, possibly even in 7.3, but it might be that in 7.3 it was just a parametric, so that may be where I'm remembering.
Well, if you're using anything older than 2017, I don't know what you're doing here. You don't want to be listening to us.
So you want to pick this drop down and go select member bearing plate. Okay, and then you select the member.
Now, does this have to be a beam?
No, it does not. You can also do this on joists, which we will get to next. So in this case, we're going to just do studs spaced. And we want it to occur at the left end of the beam. And we want to set our plan rotation, in this case, is going to be 180. And I don't want any additional setback from the work point. I want it flush with the wall. It will give you a member x-axis rotation of 90. That's just making it flat level. If it's set to 0, it actually becomes a wall plate, which we'll get into in another couple of minutes.
Okay.
So
it calls that the x-axis rotation, but it's not really the x-axis.
Right? It is. That's the member line. It's along the length of the plate itself. So the plate is going to be put in perpendicular to the beam that you're locating from.
Okay.
So I'll just show you how that works. So if we do a length of a foot and a depth of 6 inches for our standard bearing and a standard 3/8 inch plate, we can now locate where we want our holes to be, our studs to be. So let's get a spacing of, say, 9 inches. We go 1.5 on each side, and then top and bottom, we want them centered, so we're just gonna split this in half. So we'll go 3 and 3. Now if you move to the studs tab, you can pick the size and length of studs that you want to use. In our case, 1/2 by 6 is fine. And then one thing you do want to check the first time you run this on a project is the nailer holes. It will always default to having 2 nailer holes, which is great for a wall plate, but pointless for a bearing plate. So we'll set that to 0, and it'll now remember that every time we run it after this. And now we can pick again. Same thing. So now we'll go up, click on the same beam, and now we're going to go to the right end. Now you have to pay attention to where that member plan rotation is, because that's what's going to adjust where you are relative to the member line. So in this case, we're going to set it to 0. And now it's flipped around. Now just to show you what happens, I'll hit escape. If I...
No, you got to back that up. So the X rotation the first time was 90. Why is it 0 now?
Nope, so that's... When you're thinking of the X rotation, and I'll change that right now so you can see what it does. The X rotation is its location along its length, which is going to be set to 90 regardless. The plan rotation has to do with how it's turned around that line on that point on the plan where the wall and the bearing plate meet. So if I change the x-axis to 0, you'll see this turns into a wall plate.
Okay.
So I'll set that back to 90. But if I were to plug this in wrong, let's say I put this in at 0, you'll see that it spins the plate around. So rather than going into the wall, it's turned around. It's rotating about this point.
So a plan rotation of 0 indicates that the plate is going to go away from you.
Correct.
Okay. And the x-axis rotation is the rotation about the x-axis. So if we were looking down the centroid of the member, it would be spinning about
Yes. Yes, so it will be spinning it along this axis right here, which will flip it up and over.
that. And when you're making a bearing plate, the member line is perpendicular to the member line of the piece that you select.
Yes, so now when I go over, I'm going to run this again. So we're going to pick bearing plate.
So that should be a 180 rotation if I'm thinking correct.
Well, now, so here's the thing, is this rotation has to do with absolute plan. So 0, imagine a horizontal line with the plate sticking up. 180 is a horizontal line, the plate sticking down. So from there, if you know what 0 is, if you rotate minus 90, you'll get what we're after here.
So it doesn't figure based on the member.
Oh, I'm sorry, I had it set to left end. So it put it in the correct direction for what I was doing, but I was set to the left end. So I'm just going to delete that and re-add it. Pick this, we're going to go back to the right end, and now at minus 90 we get what we want. And now we're going to go left end. Imagine that 0 again with the horizontal line with the plate up above. If you rotate that horizontal line positive 90 degrees and go to the left end, we'll get again what we're after. And now over here I've got a joist. I'm just going to throw in another one. Left end again, 90 degrees, it's the same deal. Now, you see how that one put it in and it's sticking out wrong, right? So when you're working with a joist, it's a little bit different than working with a beam, because with a beam, your work point is going to be the face of the wall, and then you have your bearing on top of that. With a joist, it's the opposite, because you have to give the point that's the end of the joist for your work point. Otherwise, it'll deduct out for the bearing. So what you end up having to do here is flip it the other way. So if I run this again, pick my joist, we're going to go left end, and now I'm going to go the opposite direction and go minus 90, because I still want it to be rotated that minus 90, but now I'm thinking about hitting from the end of the joist as opposed to rotating from the face of the wall. Okay, now obviously I don't need such a big honking plate. I only need 4 inches of bearing this time, which means I only need 2 inches up and down. And now I get a different plate. And you can obviously adjust the length the same way.
All right, so let's go over those orientations again.
Okay.
The 0, 180, 90, and minus 90.
Right.
How do I remember those?
Okay, so
being the dumb guy that I am.
Okay, so think of it this way. This is your 0 rotation, okay? So this will be your member line. I'll just double that up. And then at 0 rotation, the plate will be sticking out this way. This is your reference point. That's the end of the beam, end of the joist, it's end of the member, however you want to think of it. This is what the system is going to use as that reference point to rotate around. So if you want to go 100, if you want the plate sticking down, then it's a 180 degree rotation. Okay? If you want the plate to rotate, and I'll keep this double line for reference. If you want it to rotate this way, then you're looking at a positive 90 degree rotation, with this line being your 0. So it's 90 degrees up. When you want to go the other way, it's a negative 90. Same idea.
Got it. So the important thing really is to remember that at 0, the plate goes
up.
What I'd say is up.
Yes. And that is independent of the direction of the member itself. So you have to plan the rotation. It does not determine that automatically. The only thing it determines automatically is the end elevation and the end point of the beam.
Yeah, that's probably for the best because, you know, a lot of times there's walls that aren't perpendicular to your
Right.
member. Okay, that helps. Thank you.
So now, if you're using one of the newer versions of SDS, we've got this concrete wall member, okay? And if you set up your member, as I've got here, with just auto standard connections, it will generate these wall plates. And as a topic for a future video, because it's a whole different member, oops, swipe it, get it, there we go. It will automatically input this Embed Plate member, which is different than the Embed Plate BV. Okay, it's supposed to be similar in concept, and it's got system designs to it, but this is part of the concrete embed package side of things, which, you know, you have the ability to work with these, but that's a whole separate video for us, I think.
Yeah, well, and there are some real drawbacks to those. I can't elucidate them all right now, but I know that particularly the concrete wall member type creates processing slowdowns in SDS2, which I don't know if they fixed it yet, but I don't believe that they have.
One of the little drawbacks with that wall, too, is that it considers it a live member, so it's not the old dummy miscellaneous member that it once was, so it will attempt to create connections there. So I'm just going to delete this, but we'll keep these construction lines in so you can see where the wall was. Okay, so the next thing I want to show you is what you can do with a shear plate and a wall embed type plate. So I'm going to just sort of run the same thing, only instead of setting it to bearing plate, this time I'm just going to select member. We'll set this to left end.
Now, to me, that member plan rotation is wrong based on what you told me before.
You are correct.
Aha. I would rotate it minus 90.
You got it.
Excellent. He can be taught.
So now, and we see this every now and then with jobs, although my stud spacing needs work, but so what we see a lot is we get an embed wall plate, and then they're going to field weld the shear plate onto it. So we'll set up the shear connection in the beam member edit screen, and then set that to attach to the supported member. And another thing that you can do beyond that is then break apart, so that it will actually create the shear plate as a loose member if you want it that way, or you can leave it attached so that it's shop bolted on by turning off that break apart.
Yeah, be aware, if you do break that apart, it's going to put it as a miscellaneous member.
It will.
And check out the detail that it gives you for that. Because I can't remember, but I believe it just, with break apart, it's generally broken apart, and the view is whatever view you were in when you broke it apart. Now, I don't know if that's different with the checkbox, but if you did the BM, which I think is the funniest abbreviation for a command ever, but if you use BM to break that member apart, you will get a wonky view on that piece.
When you're doing this, I don't believe it does that, but unfortunately I'm in a modeling only license right now. So when you're getting this run on the broken apart member, when it's done by the system, it will create the flat view of the plates. It does not make it anything crazy.
That's what you want.
Yeah.
So that's a nice looking detail. That's how you want it to look, with the exclusion of the clouds, which we'll forgive for the moment.
Great. Well, this is a brand new fabricator file setup. This isn't run by any of our customers, and rightfully so.
Okay. All right, so we've got a wall plate there. We've done a bearing plate. What's next?
Okay, so next up on the list, we see these every now and then. We get a moment plate that's going to be put across a couple of joists at the top of a column.
Also known as a joist tie plate, depending on the person doing the talking. All right, so if I've learned anything, you're going to draw 2 points from end to end of that plate. You're going to select a member rotation of, or a plan rotation of 0. But then you got to do some kind of setback, right? Or are you going to move the member line down?
So we're going to move the member line down, which I've drawn in a couple lines across a line across the bottom, which is going to be my member line, and then I've given us a top one just so we can see if everything fits in correctly. Now, one of the things to watch out for when you're using this is top of steel is top of plate. So I've surfaced onto the joist, but if I'm going to use a 3/8 inch plate, I need to bump up my view by 3/8 of an inch. So now I'm going to pick.
In case you don't know, the command to change the height of that view is RD, or relative depth. When you're using the relative depth command, up is a positive and down, as if you're sinking towards the floor, is a negative dimension. So he would have put in a RD, he would have hit RD, the dialog popped up, he would have put in a positive 3/8 inch dimension and pressed OK.
Correct. So when you've picked 2 points, it will start off by giving you the plate length already filled out, with one exception. The exception being if you're not set to something that's spaced, if you've just got studs, DBAs, holes, then what's happening there is there will be a set of studs in columns, rows, and spacings between the studs, DBAs, and holes that will determine a minimum length for that plate, and it will automatically bump that up if you're insufficient. So you got to watch out for that. Yeah. Sometimes you may have to put that back. Now in our case,
I really wish this worked the other way around, where if you didn't have a plate big enough, it would drop the extra studs or holes. But
6 of one, half dozen of the other, I say. But yeah, it's at the very least, gray it out, or whatever, make a warning that something needs to be tweaked there. That would be better for me, I think. But in this case, it's just going to be a plain plate, so I'm going to click plain. And again, I'm just going to double check to make sure I still have no nailer holes, which I don't. So you see how it takes away all of the fields for filling out studs and spacings based on my selection here. So now when I click on that,
you got your x-axis rotation.
I sure do, because I'm still set up from a wall plate. So I want to go back in and set this back to 90.
What have you done?
So you remember we discussed the whole it adjusts the plate size for you? It did. It adjusted the depth from 2 inches to 1 foot 2.
All right. So and then let's just show that detail quick so we can... I know you got to use the drafting station, but...
Pretty straightforward.
Yep. That's awesome.
Now, I will go back. I want to show you one other thing before we press on to the last of it. Because there is a value to nailer holes. And that would be when you're actually dealing with a wall plate. So now I can set this up to either be 2 holes and they'll be in opposite corners, just like this. You can go 4 and it's all around, or there is a 6-hole pattern, but standard for us is just 2. And you can also set the diameter of whatever hole size you want. For us, this is fine. So flip back. We'll detail this just so you can see how this comes out. And so we get our studs called out. Everything is spaced and dimensioned up. And we've got our nailer holes called. Again, forgive the clouding.
And it's pretty solid straight out of the box, as opposed to a miscellaneous member, which miscellaneous member details come out just awful. All right, so if you would, take us through using a full length, what we would call a deck plate.
Okay, so basically going to set it up, pick the endpoints. in this case, my x-axis rotation is not something I have to consider. I'm sorry, not my x-axis, the plan rotation, because that's set up by my 2 work points. So the x-axis rotation is the only thing I need to worry about, which I will set to 90. The length is put in because I've given it a 1'4", and I only want a 4-inch plate in this case. So I need a top and bottom spacing of 2 and 2. Let's make sure we've got some studs picked out, and let's lose the nailer holes.
That is a lot of studs, my friend.
Sure is. So in this case, I've got a spacing that's awfully close together. We better work on that. Let's say it is 1 foot on center.
That's better.
Fixed. Oh, but you know what? The studs are the wrong size.
1/2 by 6. Oh, that's what they are.
Let's go 1/2 by 4. Now we have shorter studs. Ah, but the engineer, he keeps changing his mind. Now he wants them at 36 inches on center.
So much
super
better.
Easy to just keep flipping this thing back and forth and back and forth. And you don't have to sit there and copy a whole bunch of materials all over the place or delete them back off.
Now, does it work with multi-edit?
So if we take one, we'll just copy it on over to the other side. Let's make it something ridiculous again so we can see all the studs. Look at that.
Beautiful. Now, can you go over the job standard plate a little bit?
So you're talking about one of these.
Yep.
So what this allows you to do is you can actually save a standard plate. So if this is a configuration of plate that I want to use someplace else, I can now save this. Oh, my caps are on. You could name it, anything that you want, basically. Okay. So now we're going to want to get me set up with something different for just a moment. So just so it will remember this is my last plate rather than the other one. If I back to endpoints and we plug this in. Now you can see we're back to a 9 spacing. We've got a 6 bearing. This has gone back to the original bearing plate. Okay. So now we should have the mat plate 1. And you can see that it kicks my spacing back out to a foot. It gives me a 4-inch depth. It puts everything back the way that I had it for that style of plate.
So it's essentially the save form dialog box.
Yes.
Because it even changed the length on you.
Yes, it did.
Okay, cool. So is it intelligent enough to give the same piece mark to that when it's rotated 90 degrees?
So let's just double check to make sure that, let's see, this is F68. F68. And our member is EM18, and this rotated one is also EM18. So yes,
Awesome.
it is.
All right, so are there any other locations where you can think of to use this, except for every place that you need a plate?
So another thing that we use this for is our landing pans when we use these in a stair. So what we'll end up doing is you get surfaced into here on the angle we want to be supporting. And then we're going to come up 1/8 of an inch. That's about the thickness of the gauge pan that we're going to use. And then I will run this member. Yep. Pick these 2 points. And I'm not entirely sure offhand what I believe that measurement should be 3 feet. And in this case, it's going to be plain, no nailers. And instead of 3/8, I want to use 10 gauge plate. Oops. I was close.
Close enough.
Length I actually needed would have been 2'11". So I'll just fix that real quick. And there we go.
Awesome. So guys, you're going to want to use these plates on pretty much every time you need a plate for a member. This is the way to go. It gives you a lot more flexibility. It gives you a lot of the ability to rotate, punch holes, put studs in, all the stuff that you really need to do with a plate type, and it's going to give you cleaner details, it's going to work faster, and your checker is going to love you.
Something I did want to show you, kind of a slick little move here, is sometimes you get where it's a plain plate with a couple of holes, and then they're going to put some anchor bolts in it.
Yep.
So if we go to holes spaced, and we leave the spacing exactly how it is, I'm going to basically swap these studs for bolts. Now, I don't want regular bolts. I'm going to put in my own anchor bolts, but I will go here, and we are set to anchor bolt hole. Okay?
Okay.
So I say okay, and now I get holes. Great. Now, if you recall from a previous video, we had the internal parametric add sag rods as anchor rods. So I'm going to set that to holes, select these, and now I'm just going to bang in something real quick, but let's make it kind of obvious. So we'll go with a hooked anchor bolt. Go with a single nut, and we'll just leave it with a standard bearing washer. Just something to get in really quick. Now, see how that popped in upside down? That's something to watch out for. If you're looking at the video that we did where it does this with leveling plates, the orientation of that member is considered a little bit differently. So when you're running it on this situation, what you actually need to do is once you select those holes and you've plugged everything in, you want to check this box, which I think I mentioned in that video, but I didn't get too much in depth because it does it right when you're dealing with that. You know, check this box to reverse the hole points. So that's going to flip this upside down, and now we get exactly what we're after. And if you want to know more about how to use these members, I suggest you check out that video, and we can get a link for that down in the description.
All right, so here's kind of a treat for the checkers out there. If you are a checker, you're going to want to tell your detailers to go ahead and incorporate this into their member custom properties. So go ahead and bring up the member custom properties for this. And in our setup, everybody's got a little bit of different setup, but with ours, we have several different places for notes. And someplace in here, in one of these that's going to show up on the drawing, I want them to tell me where this bearing plate or embed plate or whatever else goes, what the structural section is. Give me a little bit of information about this plate so that I can find it on the details. And so when we detail that plate, you'll get a note right on the drawing that tells you where to look for it. It's very, very helpful, and if you detailers out there will use this, you will make your checkers very, very happy. Yes, I am talking to you, employees of United Structural. All right, so does that wrap it up, you think, for the embed plate custom member type?
Yeah, that covers it for me.
Okay, very good, guys. If you got any questions, please let us know down in those comments. Hit those like and subscribe buttons, and apparently you got to hit that little bell if you actually want to know when we produce a new video. So hit that bell, make sure that you get all the information you need to be the best detailer possible, and we'll see you back here on the Steel Forum.